Hello guys, welcome back to the channel. In this video, let us see the next question of engineering drawing projection of planes. The question is like this. A lamina of rhombus shape has major diagonal of 200 mm and minor diagonal of 150 mm. It is resting on one of its corners on HP. The lamina is inclined to the HP in such a way that its major diagonal appears as a minor diagonal of 100 mm. Draw projections of the lamina when original minor diagonal makes an inclination of 30 degrees with VP. Now, let us break down the question. There is a rhombus shape. So, this is the rhombus shape. Generally, what do we know? So, followed by this is the XY line. If you project this one, this becomes the lamina of a rhombus. But what is the constraints here? It is having a major diagonal of 200 mm. If I join the two opposite corners, this becomes the major diagonal, that is say some 200 mm, and the minor diagonal is say some 150 mm. So this would be the initial condition. Why I am taking on a corner position? It's very clearly mentioned that it is resting on one of its corners on HP. The major constraints here is the major diagonal is 200 mm and the minor diagonal is 150 mm. Drawing a rhombus with 200 mm and 500 mm would be quite impossible, and I mean to say that we require a huge workspace. Henceforth, what I will do here is, in order to take 200 and 500 mm, I will consider a suitable scale factor. So what is the scale? Scale, let us take 1:5. I will reduce the scale factor by 5. That means to say that 200 mm reduced by 5 would get a new value, and that can be easily plotted on a sheet of paper. The first thing is I will draw XY line. I will name this line as X and Y, followed by this is VP by HP, indicating first angle projection. Now, for the initial condition, I will draw one vertical line followed by one horizontal line. Yes, the vertical line and the horizontal line is intersected at this point. Now, I will start obtaining the rhombus first, rhombus on its corner position. Before that, what is the first dimension they are talking about? The major diagonal is 200 mm. So, the 200 mm divided by 5. 200 mm, let me reduce it by scale factor 1:5. So what happens? 200 divided by 5 would give the value of 5 ones are 5 fours are. So 40. So this is 40 mm. 40 mm is nothing but 4 centimeters in the normal scale. I think 4 centimeters we can project it easily. I will make use of scale and I will mark 2 centimeters from the intersection point, either sides. 2 centimeters towards the right hand side and the next 2 centimeters towards the left hand side. So this will be the major diagonal. Similarly, the minor diagonal is 150 mm. Next, 150 divided by scale factor 5 would give you the value of 30. So 30 means 1.5 on either side. This step is not required. This is just for your understanding purpose. So minor diagonal is obtained. The next thing is, let us join the corners. Very clearly mentioned in the question, it is resting on HP and one of its corner. I will join these 2 points, move the scale. So this is the rhombus. Rhombus with a major diagonal 200 mm followed by minor diagonal 150 mm. I will immediately update the dimensions. Yes, this is the rhombus of major diagonal and the minor diagonal. It is resting on one of its corners on HP. Fine. I will call this point as point A, point B, point C, followed by the point D. Now, let us go for the projections. The projections would be something like this. Upward projection here. So, this is, let me take it to the front view. Here, we can find a lamina, the rhombus lamina. observer is looking from the bottom in this direction. So for the observer, A is visible show as it is, B is visible, D is invisible within the brackets, and dashes indicates the front view representation, C visible show as it is. So we are constructed with the first initial conditions. Yes, this point you need not show in the examination for your understanding purpose. So this is what we call it as the corner resting on HP. So this point is the corner resting. Okay, what is the next condition given here? The lamina is inclined to HP in such a way that its major diagonal appears as a minor diagonal of 100 mm. Major diagonal appears as a minor diagonal of 100 mm. So this horizontal line becomes 100. That is what they are telling. And the minor diagonal in the first position remains as it is. So the horizontal line becomes 100 means, don't you think now this becomes the major diagonal? Exactly. Fine. Now let us obtain the projection, something like this. I will drop a projection line here. I will continue. I will extend this projection line, followed by I will extend this projection line. If you're having a big sheet, you can, if your workspace is more, you can solve with 1:1 scale factor. Clear? Okay. Next, I will consider this line here. I will draw the line for the reference purpose. Okay. Now, the major diagonal appears as a minor diagonal of 100 mm. Once again, 100 mm reduced by the scale factor 5 gives the value of 20. 20 in the sense 1 centimeters, 20 mm, 10 mm on the either sides. So 10 mm this side and the next 10 mm the other side. Followed by this 150 mm remains as it is. Very simple procedure. Let me join the new 4 corners in order to make it as a rhombus. So this is the apparent shape. Let me update the dimension. Let us project it to the front view. Let us project the other corner as well, extend the line of action. Now I will make use of compass. Take compass, measure the distance from A to C. Just take the distance from A to C. So this point as the A and the C point, you just cut it on the extended line. Now let us join the 2 points, the intersection point and the initial point, followed by, let me extend this line. So this would be the point A, this is the point B, this is C, this is D. As usual, this is the point A dash, this is B within the brackets D dash, followed by C dash. Now we can measure this angle. So this is what the angle we will get, that is equal to theta. What is the next condition? Draw the projections of the lamina when the original minor diagonal. What is original minor diagonal? That is nothing but, I will just mark here itself, this is nothing but 150 mm. So now this makes an angle of 30 degrees with HP. We know the concept, any inclination with respect to VP has to be shown under HP. Now I will draw a line at an angle of 30 degree and I will finish the projection. Meanwhile, I will darken this major and the minor diagonal. Now a BD is the major diagonal, AC is the, I will just update here, BD is equal to, this is the major diagonal and AC is equal to minor diagonal. So for our understanding purpose, this major diagonal is now what we call it as the original minor diagonal. Hope it is clear. Now I will draw a line at an angle of 30 degree. I will mark any convenient point. I will measure, take 30 degrees in my protractor. Now I should transfer this apparent shape of the rhombus in such a way that BD should come on 30 degree line. make use of compass. I will check out the distance from BD. BD is nothing but 150 mm. That is nothing but, in my normal scale it is 3 centimeters after scale reduction value. Okay, I will take this distance B to D. I will cut an arc here. So I will call this point as B, the other point as D. Not to forget, there is one more point, the midpoint. You can take the midpoint or you can leave it. Now B as the center, BA as the radius. B as the center here, BA. BC is also the same distance. Let me cut one more arc. For the intersection point, I will not change the compass length. I will cut one more arc from the B and D so that it will intersect the previous arc. So this is the point A, B, C, D. Let us join the 4 new corners. A to B, followed by B to C, C to D, D back to the point A. Not to forget, let us show the major and the minor diameters. Now, the last step is, let us obtain the final position. I will go for projection from the point A here, projection from the point B, projection from the point C, and the last one is projection from the point D. I will go with the right side projection. Projection from the point A, it is already there on the XY line, not required. Projection from the point B and D. So this would be the projection from point B and D. And the last projection is projection from the point C. One by one. Projection from point A and A would get the point A dash. Similarly, projection from B and B would be the point B dash here. Projection from C and C would be the point C dash here, followed by the last projection is D, D dash. Now, let us join the 4 new corners. Point A dash to B dash, B dash to C dash, C dash to D dash, followed by D dash back to A dash. So this would be the final rhombus. Of course, they are not asked anything. If you want to find out this angle, means let us find out this angle with the help of a protractor. It's close to 60 degree. I will just mention theta is equal to 60 degrees here. This completes the projections. Hope you like this video. If yes, give this video a thumbs up and you can share with your friends. Don't forget to subscribe. Thank you. I will talk to you in the comments. Have a nice time. Bye.